learning how to write a formal proof. And we're going to do that using algebra first, because that's something you're familiar with. So how are properties of algebra used to write proofs? This is section 2.5 in your book. A proof is an argument that uses logic, definitions, properties, and previously proven statements to show that a conclusion is true. So we're trying to link definitions and ideas together to start with one given information and then to prove something. All right, so here are properties that we're going to use. We're going to use the properties of equality. The addition property of equality says that if, well, for all of these, I think we start with if A equals B, then A plus C equals B plus C. So if we add C to one side of the equation, then we add C to the other, then both sides of the equation are equal. Again, starting with if A equals B, then A minus C equals B minus C. So if we subtract C from one side, we subtract C from the other. Multiplication property of equality, A times C, B times C. So if we multiply one side of the equation by C, we have to multiply the other side. If A equals B, then A divided by C is going to be equal to B divided by C. The reflexive property of equality, I remember this one because if I look in the mirror, I see my reflection, and A equals A, so this would be an identity, so something equals itself. Symmetric is if A equals B, then it doesn't matter what way I write it, I can write it B equals A. The transitive property is a little bit trickier, and that says if A equals B and B equals C, then A equals C. So because they both equal B, then we can jump right from A to B, or A to C. And then substitution says if A equals B, then B can be substituted in for A in the expression. So those are our properties. So these are our reasons why we're allowed to do all the algebra that we've learned. And then the distributive property. The distributive property says if you have A times the sum of B plus C, you can distribute it and write it as A times B plus A times C. So for this, we're going to write a proof. It's going to be a 2-column proof. We're going to have statements. And that's kind of the what. What are we doing? Oops. And we're going to have reasons. And that's the why. Statements and reasons. So the what is, we're going to start with 4m minus 8 equals negative 12. And the why is that it was given. We're starting with that equation. So to solve this, the first thing that I'm going to do in algebra would be to add 8 to both sides. And what do we get if we add 8 to both sides? We get 4m equals negative 4. The reason why is the addition property of equality. So we're justifying why for everything. So this will be step 1. This is step 2. The next step that we would do to solve for m would be to divide by 4, and we're dividing on both sides. So if we divide by 4, we get m equals negative 1. And the reason why is the division property of equality. And here we are done. We've solved for m, so we're done. So when it says write a justification for each step, that's your reasons. Your justification are your reasons. All right, let's try this one. We're going to do the same thing again. We have statements. We have reasons. We're writing a proof. The step 1 is the easy one. We just write down what we are given. And then step 2, we want to get x alone. So what am I going to do to get x alone here? I'm going to multiply 2 times 1/2 because then I'd get 1. And whatever I do to one side, I have to do to the other. And what do I get when I do that? I get x equals negative 26. My reason why is the multiplication property of equality. All right, so now let's start with geometry and turn it into an algebraic proof. So my first step is to write down not the picture, but an equation. So I'm going to do part plus part equals whole. So I have 2x plus 3x minus 9 equals 4x minus 4. My reason why. Now that's not given to me, so this one's a little bit different. Why am I allowed to say part plus part equals a whole? Well, this is called the segment, and we learned this way back in chapter 1, segment addition postulate. And what is my first step for simplifying this? Is to combine like terms. And so I get 5x, and even though I added the x's together, I didn't add to both sides of my equation. So that is not the addition property of equality, but rather it's just simplifying the expression. So my reason why is just going to be to simplify. Step 3, now I'm going to get all my x's on one side of the equation. So I'm going to subtract 4x from both sides. And you can see that I did subtract on both sides, and I'm left with x minus 9 equals negative 4. So this one is the subtraction property of equality. And I'm going to abbreviate POE. You can do the same. My final step is to add 9 to both sides, and since I added 9 to both sides, I am going to get x equals 5, and that is the addition property of equality. And this question, it didn't say to solve for mn or no, so I'm going to be done here after I find x. Otherwise, I could keep going, I guess, and find, use substitution, but here I'm going to be done. All right, pause the video, try this one on your own. My first step is to do part plus part equals a whole. 1 part, 2 parts equals the whole. The reason why, similar in the last example, except for this is not a segment. This is called the angle addition postulate. Step 2, I'm going to combine like terms. 9x minus 11 equals 8x. And because I didn't do anything to the right-hand side of the equal sign, it's not a property of equality. So this is just simplifying the expression. You could write combine like terms. That wouldn't be wrong. My next step is to get x alone, so I'm going to add 11. Oh no, I'm not going to add 11. I am going to try to get all my x's on one side. So I'm going to subtract 9x from both sides. And so that is going to be the negative 11 equals negative 1x. That would be the subtraction property of equality. From here, I would like to get x alone, so I will divide by -1. And what do I get when I divide by -1? I get 11 equals x. Division, property of equality. And finally, we like to write our answer as x equals 11. Do you remember what that is, where you can switch the order? That is the symmetric property of equality. That's it for notes, so you can try your homework.